Welcome to our webinar, Targeting Customers Who Prefer Your Product, Market Simulator Add-on Analyses. I am Christina Miller, Manager of Client Services. This webinar will be presented by Keith Sean. Keith is Senior VP of Sawtooth Analytics, a division of Sawtooth Software that serves our clients with paid consulting services. He's been a prolific writer and conference speaker in the field of choice analytics over the last 30 years. I'll be monitoring the Q&A and chat today. We will email all attendees when the webinar recording is available on our website.
Okay, so again, as Christina mentioned, the title is Targeting Customers Who Prefer Your Product. This is a presentation about some add-on things we can do with our simulators. And although it says market simulators, that would apply to our conjoint studies and our menu-based choice studies. We could also do this with simulations we can run from MaxDiff as well, or from any other kind of choice experiment we might choose to run. So anytime we've got a simulator that gives us shares of anything, we can run these analyses. They're not things that are currently built into our Sawtooth software simulators. They're something you're going to have to do outside of Sawtooth software. But still, there's some value add things you can do that occasionally I know my customers ask for. In fact, I think in the past month or two, we've done each of these things a couple of times. So anyway, here we go. So here's some ad. So by way of background, we do whenever we have our choice-based experiments, whether they're conjoint or MaxDiff or menu-based, we can construct preference share simulators. And when we're typically simulating from respondent level utilities, so that means we have the share of preference information for each product for each individual respondent. And typically we use simulators to report things like share of preference or sensitivity analysis, or sometimes we do product or portfolio optimization or willingness to pay. But there's a lot of things we can do with our choice simulators. And so we end up delivering something that looks like this, right? An Excel simulator. So here we've got three products A, B, and C with a none alternative. And each product is specified in terms of the brand, the warranty, the number of bells and whistles. Those are, you might imagine, those are add-on features that we could add, what color the product is, and price. And as you can see, this is a very disguised study. As I'll mention in another couple minutes, my client allowed me to use the simulator, but they insisted that it be disguised, heavily disguised, in some silly ways, like we have to use different brand names, right? I can't think of a market where Acme, Ford, and American Express are in competition. Maybe there is one, but I can't think of it. But this is all, the data is real, but the labels are made up. Anyway, this is the kind of thing we're typically delivering in our simulators, right? We've got products, and down here at the bottom, we've got shares of preference. So for this particular version of Acme versus this particular version of Ford and this particular version of American Express, 23.78% of the people prefer the Acme product. 13% of the people opt out of choosing altogether, and so on. The typical simulator type stuff, right? But what I want to talk about today are things that we can do in addition to that standard simulator stuff, right? We can use that respondent level share of preference information to think about targeting customers, right? And we can do that a couple different ways. The one way that I'll show you first is we can dynamically profile the people who are likely to buy our brand or who want our new feature or our new product or whatever. We can do that right inside Excel. The other thing we can do is we could build tree-based classification models to identify target segments. And so let's talk about both of those things in turn. So we could, in other words, we can target people in terms of things outside the choice experiment. We can target them in terms of their demographics or behavioral variables or attitudinal variables. We could profile the customers on all of those things, and we can look at them by whether they they choose a given product or not in a simulator. So we might expand our simulator to look something like this. So here we have our standard share simulator at the top, and down at the bottom, I've listed just a large number of demographic, behavioral, and attitudinal variables down along the side here. And again, the labels, I was forced to disguise this. So we've got male and female, we've got segment 1, 2, and 3, whether they shop online or at retail, how often they use things, and so on. So we got a bunch of different variables. And what you could imagine in a simulator like this is that we could just put in, we could show, looking at male and female, for example, we could show the percent male and the percent female who preferred, among those people who prefer product A, among that 23.78% of our sample, how many are male and how many are female? Or how many are segment 1, how many are segment 2, and how many are segment 3? Unfortunately, my client didn't allow me to build to show you the simulator in that way. They wanted me to show indexes instead. So instead of having numbers that would probably be more useful to see, we're looking at indexes. But the thing I wanted to show you, and let me just get out of this for a minute and into Excel. If we look at this in an Excel workbook, and I think you can see that now, as we change the product, let's change Acme from having a 90-day warranty to a lifetime warranty. And what you're going to see is the numbers down below in the profiling section are going to change. If we give it a better price, let's say we drop the price to $1 instead of $2, we're going to see the numbers at the bottom change. If we change the color from silver to a much better color, orange, we're going to see the numbers change. And again, if you can imagine, you can either do indexing like I've done here, or you could just show the shares themselves. What percent of the people were segment 1, 2, and 3? Or maybe these are attitudinal ratings on a 5-point scale or something, and we want to show a mean on a 5-point scale. So we'd say, of the people who chose product A, what was their mean score on this attitudinal attribute, or top 2 box score, ever how we want to do our rating scales, right? And you'll notice that when we made some of these changes, our share of product A went from 28 to 47% of the people. So when this profiling is happening down below, it's happening among that new base of people, right? So whereas these were indexed to that 28% earlier, they're now indexed to this larger sample of 47% of our sample now. Anyway, that's a way to do what I'd call dynamic profiling within the simulator. So we can change our product in whatever way we want, and we can look at the profile of who our likely buyers are. Okay, so let's get.
Hey Keith, quick question.
Yes.
So this came up. Thanks for sharing the output. Is the interpretation of the index meant to show leaders and laggards so that a 1.3 index per prospective Acme customer for product B means that the prospective customers are 30% more likely than uninformed average propensity to purchase product B?
Yes. Yeah. These are indexed based on the average share of the group. So when the longtime user here that shows 1.02, what that means is for the total sample, whatever the share was, the sample for these longtime users is 2% higher than that. There's another way to sample, right? We could say, well, for the total sample, X% are longtime users. And in this sample, this sample is, 110% times that X%, right? So we could index, I've indexed it here based on the shares because that's how my client wanted it. We could base it on the variable itself. We could have that be the basis for the index. But I find these, when I deliver these, I tend not to deliver indices like my client insisted on. I tend to deliver the raw information. What percent are long-term users? What percent are newbies? And so on. But again, this is the way I was allowed to share it with you. So that's all I'm doing. Hopefully that clarifies.
Thank you.
Okay.
One last question, if you have the time. How is profiling done for non-first choice simulations? If we've done a share of preference simulation, right, we've just got a
you're right. We'd have to, we could either weight each respondent, right? So one way to do it would be to weight those demographics, variables, the behaviors, the attitudes. We could weight them by the share of preference for each respondent, or we could pick the modal response, right? The one with the highest probability, and pretend we had first choice. We could do it really either way. And adding weights and adding the weighting in there is an extra step, but mathematically it's not a huge extra step. So that's typically how I would do it rather than simulate to first choices. Good questions. Good questions. Okay, let's pop back into PowerPoint now. So we reviewed this. We talked about the profiling simulator. And for the rest of our time together, I want to talk about a different way of targeting customers. Myself, I think this is a little bit more powerful. It uses tree-based modeling. So the in-simulator profiling we looked at a minute ago looks at demographic, behavioral, attitudinal characteristics one at a time. In the case where those characteristics interact, a tree-based analysis is going to segment respondents into more discriminating groups. In a way, the tree-based target identification is going to do more concisely what I think the profiling does a little bit less well. But that's just me because I like running tree-based models. So maybe I'm a little bit biased here. But in any case, I want to show you both of these options because from time to time, we deliver both of these to our clients. So before I get there, I want to do a brief introduction to trees, right? So to help me introduce you to trees, here's a Corroboree tree frog from New South Wales, Australia. Here's some images. I went online. I've never been to New South Wales, Australia, so I wanted to see what it looked like. And apparently there's a lot of different kinds of terrain in New South Wales, Australia. We've got, green, we've got some verdant, pondy sorts of areas on the left here, and some dried out, scraggly looking places to the right. And of course, we all know the famous German proverb, where there are no swamps, there are no frogs. So maybe we'll go ahead and we'll look to see if we can find some data to back that up. That's how the Corroboree tree frog is going to come into play here. I went online and I found a data set that has a sample of 212 locations in New South Wales, Australia. And 78% of those locations, 78 of those locations had frogs, and 134 of them didn't have any Corroboree tree frogs. In addition to, my data set then, in addition to telling me whether the Corroboree tree frog was absent or present, it told me the longitude of the location, the latitude, the altitude. It told me annual temperatures and average spring temperature during the mating season of the tree frog. It told me the amount of spring rainfall. It counted the number of nearby ponds, and it measured the distance to the nearest breeding pond. And we want to see which of these things are predictors of whether we've got Corroboree tree frogs present or not. And we're going to do a little tree-based analysis for that. So I hop into R and I build my little decision tree. And here's what it gives me. It tells me that this is my final predictive model. This is what a tree looks like, okay? And just before I go on, I want to introduce you to some tree language here. We've got a dependent variable. That's the number of frogs, or the percent of locations that have frogs. And we saw it was 37% of all locations. And as we go down the tree, you can see that as we're splitting our sample into smaller groups here, we've got a group here that's 137 people that has a 20% frog incidence only, and another group with 75 locations that has a 68% frog incidence. So that's our dependent variable, and we want to see it become as discriminating as possible as we move down the tree. And then we've got some predictor variables. The predictors are the things that make the splits in the tree happen. They're the things that make the tree branch. And the first predictor variable in our model is distance. Are we more than 624 meters from the nearest breeding pond, or less than 625 meters? And if we're less, we're much more likely, we're over 3 times as likely to see frogs as if we're more than 624 meters away. And then within this group here, we have another predictor variable, the minimum amount of spring rainfall. If there's not a lot of spring rainfall, then there's only a 17% chance of finding frogs. And if there's a lot of spring rainfall, we've got a 78% chance of finding frogs. So that's what That's what a tree looks like. So some more language here. Each one of these groups is called a node. It's a group of respondents when we're doing when we'll be doing our studies based on our simulations. But right now, it's just a group of these are groups of locations. And then finally, this act of branching the tree is called a split or a partition. It breaks the tree into subgroups. Typically, our splits involve only one predictor variable at a time. Most trees use binary splits like I've shown you. And at each node, the tree splits the sample using the most significant predictor. So what the tree did at the first node, back when we had 212 locations all in one pile, is it looked to see the single variable that was most discriminating in terms of whether there were tree frogs present or not, and it turned out to be distance. And so it split us into bigger distances and smaller distances. And then for each of those, it looked to see, well, can we split it further? And it turns out that when the distance was greater than 624 meters from the nearest breeding pond, no more variables allowed us to split that sample any further. And so it stopped. So we have a node that ends right there. Doesn't split further. But on this side, on the right-hand side, we can see that there was another split that allowed us to, that was based on the amount of rainfall. And so, and then of course the analysis looked at both of those subgroups and looked to see if it could split them further, and it could not. So it stopped there. We have a little tree that ends in 3 nodes, and we call those ending nodes our terminal nodes. Means they're the nodes that can't be split any farther. Sometimes they're called leaves just to keep up with the arboreal analogies. A little bit more information about tree-based models. Trees are a kind of supervised learning model that use recursive partitioning. And that sounds really fancy. It just means that we have a dependent variable. That's what supervised means. There's a dependent variable, and that we split the sample again and again. And that's what recursive means. We repeat that process of splitting the sample. Of course, we can charge a lot more money for our work if we call it recursive partitioning, because that sounds a lot cooler. So we use names like that. There's a couple different kinds of trees. If we've got a dependent variable that's categorical in nature, maybe if we've broken our respondents into mutually exclusive high, medium, and low likelihood groups, say, we could do a classification tree. But what I'm showing you today are regression trees. We've allowed our dependent variable to be share preference, which is a continuous variable. Okay, so now let's go ahead and apply trees to our choice model simulations. And again, the dependent variable could be the share of a product or service in a conjoint study. It could be the share of an item in a max diff study, or perhaps in a menu-based choice study, it could be the total dollar spend. And I'm going to show you a couple different examples in a couple minutes. And our predictors can be things like demographics, behaviors, attitudes, or any other variables that could allow you to target your customers. What magazines they read, what TV shows they watch, what their hobbies are, anything like that, that would be useful for targeting, we can throw into the tree-based model and see if it's predictive or not. And so here I'm going to show you the first of the 2 examples I'm going to show you is a regression tree for a service. Okay, so we start off with the total sample. I had 1,580 respondents in this study. And when we ran our base case simulation, the simulation that the client thought would represent the world as it was when they went to market, their product, we found out that their product had a share preference of 36.7%. So a little over a third of the people wanted to acquire this new service that our client was going to be offering. So the tree algorithm searches for the most discriminating way to split the total sample, just like it did ponds or locations a few minutes ago. And now what it finds is that the first discriminator is the most discriminating variable is age, whether someone is over 64 or not. So if someone is not over 64 years old, they split to the left, and only 16%, if somebody is over 64 years old, they split to the left, and when we see there's a 16% share for our product among those people. And if they're under 65, we see that there's a 61% share for those for our product among those people. So that's interesting. As the tree continues to build, the branch on the left side splits again based on whether someone is over 64 or not, and whether they have a safety concern or don't have a safety concern. So the people in the leftmost box, in the lower left corner here, those are people who are both over age 64 and who don't have any particular safety concerns about the product, about their product for which this service applies. And we see that among those people, only about 10% want to buy the service that we're going to be offering for their product. If they're over 64 and they have some concerns about the safety of their product, then they're about a third of them are interested in acquiring the service that accompanies the product. As we keep going, we see the right-hand side also splits. So the younger folks who are under 65, who accounted for about 60% of, who had, among whom 61% were interested in acquiring our new service, split further based on whether they're recent purchasers or not. If they're not recent purchasers, they go to the left, and only 42% of them are interested in our service. If they are recent purchasers, then over 2/3 of them, they go to the right, and over 2/3 of them are interested in our product. And finally here, we see one more split was significant in our tree. Among those non-recent purchasers who are under age 65, some of them perceived owning the product itself as a hassle, and some didn't. If they did perceive it as a hassle, they split to the right, and there was a 60% chance they would buy our new service. If they didn't see it as a hassle, they thought, oh, I can do it myself, I don't need the service, and only 30% of them were interested in acquiring the new service to accompany their product. What we can see is that we've got two segments of especially high share of preference for our service. So we should be looking at people who are under 65 years of old and who purchased recently, or people who are under 65 who haven't purchased recently, but who perceive ownership of the product itself as a hassle. Those are people who are going to want our service too, because they don't want to deal with the product themselves. Okay, so you can see here, I mean, we've identified groups of people that are differentially interested in our product by a factor of almost 7, right? So we got 67% over here on the far right. We've got 10% down here on the far left. Using just 3 variables, how old someone is, whether they 4 variables, whether they purchased recently, whether they're concerned about safety, and whether they view ownership as being a hassle. So we've got one behavioral variable, recent purchase, a demographic variable, age, and 2 attitudinal variables. So using just those 4 variables, we can really find high concentrations of potential target customers, which is kind of cool. That's what we want to do with targeting, right? That's the goal of targeting, is to identify groups we can who are amenable to our marketing. Of course, the growth stops when no further splits can be made. We talked about that a little bit with the frogs up above. Trees, there's 2 main ways to build these trees. One, it uses an algorithm called classification and regression trees, or CART. It grows the tree fully out. It grows it as far as it can, and then it prunes it back. And in my experience, this pruning process, it adds a complexity parameter, and when trees get too complicated or too branchy, it prunes them back and says, look, the additional explanation isn't worth the additional complexity, don't do that. Those trees usually end up to be slightly smaller than trees that are built with conditional inference, which is another tree building method. And these trees branch out as long as they can keep making significant splits. There's no pruning that goes on. Instead, they use a modified Bonferroni procedure, one that's unique in that it doesn't penalize attributes with smaller numbers of levels. I'll let you can read the papers about the conditional inference if you want to see why that's important. But the result for what we care about today, the result is that we end up with a slightly bushier tree. Sometimes you're going to want your trees to be a little bit bushier, and sometimes you're going to want them to be less complicated, less branchy, less bushy. And that's often going to be a function of sample size, right? So if you're dealing with a relatively small sample, you're likely to end up with a pretty small, not very complicated or interesting tree. Whereas if you start off with a really big sample, you're going to end up with a tree with lots of branches, potentially so many branches you can't even show them on a PowerPoint slide, and then it kind of loses some of its utility. So I usually run it both ways and see which way explains better, which way my client's going to be able to use better, which way I'm going to be able to report better. I want to show you one more example of a decision tree. This is the first tree was a conditional inference tree for that service. This is a cart tree for a consumer durable product. And you can see here we had a total tree, 1,800 people. The percent of people who were interested in this durable product was 28%. They were using it for different reasons. People who used it for usage number 2, again, I've had to disguise these results a little bit, but people who used it for usage number 2 out of 3 had a 44%, whereas people who used it for usages number 1 or 3, for purposes number 1 or 3, had only a 26% share of interest in the new product. Among those usage equals 2 folks, we split further based on whether they're younger, under age 45, or whether they're 45 plus. And those under 45 people have a 52% share likelihood of buying our new durable product, whereas the over 45 folks were less so, about 38%. And then on the other side of the tree, after usage, it's split on whether the products are perceived as being easy to use or not, an attitudinal variable, and then another demographic variable further down, whether the respondent was male or female. And what you can see here is the differences aren't quite as stark as on the previous tree, right? On the previous tree, we had almost a 7x factor between the most likely group and the least likely group. Here, what we can see is we've got something of a niche product here, right? So we got here our high probability segment, where more than half of the people want the new product, is only 68 out of our 1,800 people, right? So it's a small segment. It's definitely this product sort of has a niche appeal. And then you've got other segments that are as small as 23% share. So anyway, you can see how we've discriminated as well as we can for this product, even though it's not quite as dramatic as the previous one. So by way of summaries, we've covered today two ways you can profile likely customers based on your share of preference simulations. You can build a custom Excel simulators to do the dynamic profiling that we showed earlier. And we can profile the most likely choosers of any or even each of the simulated products. If we want to profile the customers of our competitors' products as we enter new products, we could do that as well. I'm not sure how actionable that information is, but we could certainly do it. And then again, we can build tree-based classification models to find groups that are maximally discriminating. And that involve interactions among the characteristics, right? So, and an interaction in a tree, just by the way, so go back to the previous slide here. If the tree is asymmetrical, if after a split, the next variable used is different on the left-hand side and on the right-hand side, we have an asymmetrical tree, and you could think of that as being an interaction, right? So. You're automatically measuring interactive effects between the characteristics here, which is kind of cool. And you might or might not, with that profiling, that within an Excel simulator profiling, you might or might not identify. You'd certainly identify that usage 2 had higher share than usage 1 and 3. But unless you knew to look for it, you wouldn't further look for the fact. You wouldn't further break usage 2 into older and younger age groups like the tree did for you. In fact, I could even imagine doing this tree-based analysis first and then doing the dynamic profiling second. This might help you find some interesting splits in the dynamic profiling to use. Anyway, we talked about both of those ways of doing it. I've got some references here if you want to read more about trees. There's some really good papers here. And I should say, time for questions now. If you asked a question in the chat function, it didn't get answered, or if we don't get to it today, or you're just too shy to talk, send me an email. I clearly like talking about this topic, and I'll be glad to trade emails with you and answer your questions. But for now, I'll turn it over to you.
We did have one question. Can you use this, I think it's referring to the tree, to figure out how to increase a share in any of these nodes? For example, how can we increase our share in not recent purchaser?
Oh, certainly. So what you could, let's see. Oh, that would actually, for that, I think you'd be better off just having a segment in your simulator so that you could look at shares among just those people who are non-recent purchasers, and then find out how to optimize your product for those people. So I think that would just be a standard way of using a segmentation variable in a simulator.
Great. Another question we had is, in the tree approach, do you use the conjoint utilities?
No, I mean, you could, right? I mean, there's no reason, those are continuous variable too. You could use the utilities themselves if you wanted. And I can tell you, back in the days when we did old-fashioned ratings-based conjoint, and we didn't feel as comfortable doing share simulations, we sometimes did use the utility itself to, find those people for whom this has the largest utility. More often, however, if we're building simulators and talking about shares, it might make more sense to think about profiling in terms of what maximizes our share rather than what maximizes our utility. Although obviously those should be pretty closely linked.
Another question we had was, are the binary splits predefined in the tree? Does the program automatically find, for example, a variable 4 or 5 states?
Not sure I follow the question. The variables, so any one of those variables might have, like male and female just has basically 2 levels, right? Or maybe nowadays we have male, female, and other, right? So we've got three levels to that variable. Maybe if we had, let's say we had regions of the country where we have our 7 census regions, right? So the analysis, the tree analysis goes through and it looks for all the possible ways to split those regions. We could look at the even numbered regions versus the odd. We could look at regions 1, 2, 3 versus 4 through 7, 1 versus 2 through 7. It looks at all possible splits. That's part of what the tree is doing, is it's looking for all possible ways to split on that variable, and it picks the way that's most significant. You could think about it as or being most discriminating. So the splits themselves aren't predefined, but the levels of the variables are, and all possible splits are checked out. Now, when you run the tree analysis, you tell it if you've got a categorical variable, it'll do things like, it'll look at things like odd versus even or 1 versus 2 through 7. If you tell it it's a continuous variable, it'll only split adjacent, it won't, if you have an attitudinal variable, say with 7 categories, it might split between 3 and 4 or between 5 and 6, right? But it's not gonna say, levels 1, 2, and 7 of this 7-level variable versus 3 through 6. It's not gonna make a nonsensical mishmash of your attitudinal variable.
Thank you. Another question we had was, can you show or explain the steps to take the output from a MaxDiff exercise to use in a cart tree? Some people are wondering what the precise steps are in making these trees.
Oh, okay. So let's say we ran a MaxDiff and we've got some number of products, A through K, say, and we're interested in what share we think product A could have. Maybe these are ice cream flavors or something, and flavor A is Tutti Frutti, and we want to find out. We want to profile who the likely Tutti Frutti buyers are, right? So we can take the utilities and we can calculate shares from them, just like we could in a conjoint, right? We just pretend that each one of the flavors is a separate product in a conjoint simulator. You could also do this if you use our MaxDiff analyzer, our online analyzer tool. You can do simulations there as well. In any case, whether you've done that in Excel or in SPSS or R or whatever, however you've calculated your shares, what you end up with is a share for item A in your MaxDiff, the Tutti Frutti flavor. And that for each individual respondent, that's going to range from 0 to 100%. And that's the dependent variable in your tree. That's when you hop into R to build your trees or whatever software you're using to build your trees, you're going to specify that as your dependent variable. Hopefully that helps.
Thank you, Keith. It sounds like that is all the questions we have today.
All right. Well, I guess we've wrapped it up a little bit early, so we'll give everybody their time back. And thanks for joining us today. Again, we'll send you an email when the video is ready. If you didn't catch the whole thing, or you tuned in after the frogs and, oh no, I missed the frogs, I really want to see that part. you can grab the video once we make it. And again, send me. I'll be glad to answer any questions. You send me an email. That's it. Thanks very much. Bye.